This is my third project about weather and crime rates. Specifically, I want to know what does weather tell us about crime displacements. So crime displacement is actually a research field in criminology. Scholars in criminology observe the phenomenon that criminals relocate crime to another period of time or another location when they did not commit the crime successfully. A lot of researchers have offered possible explanations for that, which include social interaction theory, social learning theory, and just regarding criminals as human beings who perform cost and benefit analysis. And there are a lot of empirical studies out there just to explain or try to see whether crime displacements actually happen. But one problem with the empirical study are that crime rates are serially correlated, which makes it difficult to identify the magnitude of crime displacement effects. So what I mean by serially correlated is that crime rates in time period t-1 is usually correlated with crime rates in time period t. This happens because criminals' behaviors in several periods can be affected by some persistent factors, and this prevents us to see the magnitude of crime displacement effects. The possible solution for serial correlation problem is just to have another variable as an instrument variable, just to replace the crime rates in period t-1, so we don't have this serial correlation problem. So empirical evidence have suggested that weather conditions such as temperature and precipitation are strongly correlated with crime rates, which makes weather variables as a pretty ideal instrument variable. And for the theoretical part, we just want to use the weather variable to replace crime rates in period t-1 to explain crime rates in period t. So this is a screenshot of the research note I'm writing. And we can see the general regression model, namely the second stage model, looks like the following. The left side is just crime rates in time period t, and that's what we want to explain. And on the right side, we have crime rates in time period t-1, and that's the endogenous variable that we want to get rid of because it's correlated with the dependent variable. So I introduced another stage, namely the first stage regression. So I replaced crime rates in t-1 with instrument variable, just the weather variable. And now I can put the first stage into second stage and try to explain crime rates in time period t using weather variables instead of the endogenous variable crime rates in time t-1. So that's the theoretical part, and my empirical data comes from FBI's National Incident-Based Reporting System. I constructed a panel using data from 33 counties from year 2000 and 2006. The counties I selected have a pretty great diversity, just in populations, in size, and in frequencies of criminal activities. I also collected weather data from National Centers for Environmental Information. The information available includes daily maximum and minimum temperature, daily precipitation, and snowfall. This is a quick summary. On average, there are 13 counts of violent crimes and 31 counts of property crimes every day across all counties in the sample, but they have pretty big standard deviations. As I mentioned before, the counties I selected vary in size, population, and frequencies in criminal activities. So I normalized normalize the crime count by dividing the average number of crimes across all time periods in one county. So the normalized crime count would be around 1. For the weather data, I only use temperature and precipitation as measurements of weather conditions, as the data on snowfall are not sufficient enough. The average daily temperature is 55 Fahrenheit, and the average daily precipitation is 0.1 inches. So here's the regression results. Before I explain the results, I just want to say that I categorize crimes in 2 pretty broad terms. One is violent crimes, which basically include murders, rape, and sexual assault. And the other category is property crimes, which involve robbery, burglary, larceny, and car vehicle thefts. The reason that I split the crimes into these 2 categories is that I believe criminals committing violent crimes and property crimes are probably pretty different when they want to commit crimes. So for property crimes, I guess that criminals are trying to gain financially. But for violent crimes, sometimes criminals are just motivated by an emotion or a plan to revenge. So that's why I split the category and did 2 regressions separately. So this is the results for violent crimes. And so there are 8 columns I presented here. Every 2 columns is a group. The first column is always the ordinary least square model, and the second model is the instrument variable model. So I just want to list these 2 models together to see how introducing an instrument can actually change the results. So for the first group, I only have crime rates in time t-1 as an independent variable. So you can see the coefficient in OLS is just 0.56, and it's positive. And in instrument variable regressions, the coefficient is minus 0.49. So there's a complete change of sign here, which indicates that introducing weather as an instrument have significant effects on how we perceive crime displacements. So the OLS model is basically saying that if you commit one more crime in period t-1, there will be a 0.5 increase in period t. But the IV model says if you commit one more crime in period t-1, there will actually be a decrease, around 0.5. And we can see that we have 4 groups here. I included different lags. So the first group just have the first lag, and the second group has the first and second lag. The results are pretty consistent, as you can see, as it's also pretty statistically significant. The results for property crimes are basically the same. The OLS model usually have a positive coefficient, but the instrument variable model usually have a negative coefficient. One thing about this result is just that I don't have statistical significant results in instrument variables. I split the individual category of crimes just to see how robbery, burglary, larceny, independently, how they correlated with weather. And I found that the correlation is not strong enough. So that's one explanation for why I cannot get statistical significance in this. Any other possible explanation is that I just don't have enough data, so the results are pretty weak. The summary of the regression results is just that the crime displacement effects do exist, and based on quite different results from OLS and IV models, we conclude that it's necessary to introduce instrument variables to solve the endogeneity problem. As before, we only knew that the endogeneity problem existed, but how serious is the problem? And for violent crimes, crime displacement effects seem to be pretty strong. Depending on the models you're looking at, the percentage of crime displacements range from 50% to almost 100%. And for property crimes, there is evidence that crime displacement effect exists, but the data does not support such conclusion with statistical significance. So as I mentioned, at this point, I might just collect more data to see whether it can improve my results. And I will just continue to write my research note and later submit it to my mentor for revision.